So in the last video, we learned how to find the delta G right here using the cell potential right there. Remember that F is Faraday's constant, is given down here, and then the N is the number of electrons transferred, and it's given. So if you forget, it's right there. So you have to use the half reactions to figure out the number of electrons. You can also find the delta G. Once you find the delta G, you can get the K equilibrium from there. So remembering that K equilibrium equals the amount of products over reactants. Very simple. So once you get delta G, you just plug it into this equation and solve for K. That's it. Very simple. So let's try a problem. So here are the formulas. Here is delta G using the cell potential right there. And here is delta G. To find delta G, or using delta G, you can find K equilibrium. You can also find K equilibrium using, this is natural log, this is the log. All you have to do is multiply it by 2.03, negative 2.03 to get the same answer. The natural log and log are related in this way. If K equals to 10, natural log of 10 is going to be, go ahead and plug that in, 2.303. So the log of 10 is 1, so you have to multiply by 2.303 to make it be equal to each other. So this is another formula that you may see, but you will not be using it. So you'll be using this mostly because that's what's on the formula sheet. So let's try using it. So here, we were able to find delta G. Now we're going to find K equilibrium. The formula is, let me just go back there. Delta G equals negative RT ln K. Okay, so delta G is given here, negative 170 kilojoules per mole equals negative R is, you're going to use 8.314 J over mole K. And I'm going to try to get rid of the joules to match this kilojoules here. So I'm going to multiply this by 1,000 or divide by 1,000. So that is, all of that is R. The temperature is 298 Kelvin. They should give you that in the problem. And I believe they did. Okay. And then you solve for ln of K. All right. So when you divide these two numbers by this, you're going to get 68.6, which is going to be equal to ln of K. To get rid of the natural log, you do E on both sides. Okay, that will cancel that natural log. So K equilibrium is going to be equal to E to the 68.6. And you will see that is going to be 6.3 E29. And that is the K equilibrium. Okay. On your own, you can do letter B. The answer should be in the textbook. It's the same exact process, but just to let you guys know, here it's if you look at the equations, this is exactly half up here, which means if you have half, you're going to have half the number of electrons, which means delta G will be half as well. Okay, when you take that, which means you have half the free energy because you have half the electrons, but you will be using the same voltage each time. Okay, so try that on your own.